Hello class, so in this video we're going to be talking about related rates, so I'll just give you some strategies and then just a few examples of how to apply those. Alright, so what exactly are related rates problems in the first place? So essentially they're problems where you're given information about rates and other quantities in a system, and you want to find some other information about that somehow. So just some strategies and guidelines. First, draw a diagram, a simple one specifically. So essentially just draw something where you have like dots, lines, circles, things like that. If you try to draw an actual, like, for example, like you have two cars or something, if you try to draw actual cars, you'll waste time and it won't be as helpful as if you just had a dot to represent each car or something like that. Alright, so what you also want to do is write down the information that you know. So read through the paragraph or whatever you have, write down the information you know, and then write down what is your goal. So you have essentially where you're starting and where you're ending. And that should help you derive any sort of relationships between start and end. And then since we're doing rate related stuff, you're probably going to be taking derivatives of things. So let's just try doing that then. So I will be underlining things blue if they are given, and then red if they are things we need to find, just for color coding. Alright, and yeah, so let's read through this and see what we have here. And yes, I watch anime, so that's why my examples will have anime in them. Alright, so the Survey Corps is trying to find a breach in wall rows. It gets dark, and they can't quite continue on at night. They came across Castle Utgard and set up camp in there. So is this information really necessary? To set up, yes. Well, set up the story at least. To set up the actual problem, not really. So let's keep going. Don't worry about any of that stuff necessarily. Alright, while organizing the place, Connie puts a 10-meter ladder against a vertical wall inside. Okay, so this is important. 10-meter ladder against vertical wall. Alright, Sasha accidentally taps it, and the bottom starts moving away from the wall. So bottom starts moving away from the wall at a constant rate of 1 meter per second. Alright, so now we're trying to figure out how fast is the top of the ladder sliding down the wall when the bottom of the ladder is 6 meters from the wall. So let's just draw a diagram real fast. So let's just say that's a wall. That's the floor. That's the ladder. So I'm just going to do this to show which part of the wall is the part that we are looking at. So this is the outside, this is the inside of the wall. Here's under the floor and stuff. So what do we know? We know 10-meter ladder against the wall. And then the bottom starts moving away at a constant rate of 1 meter per second. So let's just call this direction X and this Y. So what we're given then is dx dt, so the change in X. What does X represent? It represents the distance between the wall and this point. That's what X is. So dx dt, it's increasing because the thing is moving down, right? So 1 meter per second. So this distance is increasing. And find how fast is the top of the ladder sliding down. So how can we write that in function form? How fast is y changing, basically? So what is dy dt when the bottom of the ladder is 6 meters from the wall? So 6 meters means x equals 6. Alright, let's try to figure this out then. So we have a right triangle, which means we can apply the Pythagorean theorem here. So let's just do that real fast. X squared plus y squared equals 10 squared. Alright, so we need dy dt, so let's just take a time derivative here. And then we will get 2x dx dt plus 2y dy dt equals that thing squared is just a number, so you take the derivative of a number, you get 0. Okay, if we simplify this over, we get 2x dx dt equals negative 2y dy dt, and then you can divide out a 2, and then you want to get dy dt alone, so we get dy dt equals divide over a negative y, so just negative on the outside, x dx dt all divided by y. Okay, so we know dx dt. We know x. But do we know y? Not directly, but we can figure it out. Because we have this equation right here. So let's just plug that directly into there. I'm just going to do that in yellow down here. So x is 6. 6 squared plus y squared equals 10 squared. So y, that's just going to be the square root of 10 squared minus 6 squared. So we'll get 100 minus 36, so square root of 64 equals 8. Okay, so then this is going to be negative. X is 6, dx dt is 1, and y is 8. So negative 3 over 4. And what are the units? Meters per second. All right, so let's try another one. So we got more anime here. All right, so Yukihira Soma is making a special type of ice cream cone dish. It consists of an ice cream cone in the shape of an inverted cone. Okay, so we need that information, so let's just circle that, inverted cone. With a radius of 2 centimeters and height of 4 centimeters. That's important. Let's write that down, or underline it. It is made a special way. The cone is held in a special cooling device with a machine dripping the liquid into the cone at a constant rate. So into the cone at a constant rate of 2 centimeters cubed per minute. This allows the ice cream to properly cool to Soma's liking. Find the rate at which the ice cream level is rising. So we see here that this is what we're trying to find. The rate at which the ice cream level is rising when the ice cream is 3 centimeters deep. So let's draw a picture of this and then work through it from there. So inverted cone means it's going to be like this. Okay, what do we know about it? So we know that this is 2 centimeters, and I'm just going to call this big R. And I'm just going to color code that so that it's easier to see it. So big R equals 2 centimeters. And then the height, the total height here, I'll just call that big H. It is 4 centimeters. All right, and then something that might also be important then is to get a little bit of a parametrization of these parts. So I'm just going to call that R and small h. Okay, so what are we given? We're given that big R equals 2, and then big H equals 4. And also the volume is changing because it's centimeters cubed per minute. So the thing is filling at that rate. dV dt equals 2. I'm just going to leave the units for this for space reasons. All right, so now we need to find something. What are we finding? The rate at which the ice cream level is rising. What represents ice cream level? H. So dH dt when what happens? When H equals 3. All right, so let's find some relationships here. Volume is necessary, so obviously we'll have volume. Volume equals 1/3 pi r squared h. And we want to find dH dt when h equals 3. So let's see how we can We don't know r just from h equals 3 necessarily. So let's see how we can relate h and r. So if we actually look at this closely, we'll notice that that cross section is going to be a right triangle with another right triangle inside of it. So we have r and h as these small measurements, and the big measurements are big R and big H. So they're proportional, right? R and H, how are they related? Well, they're related in the same way as small r and small h are related. But we actually know the values for big R and big H. So let's just put those in. So 2 over R equals 4 over H. So if we do that out, then we get 2H equals R times 4 times R. So we want to have something with just H's because that's just going to be more convenient for us. So let's actually just write this all with H's. So let's get rid of R. So let's isolate R. R equals 2 over 4H. In other words, 1/2 H. Or you can just think of it as H over 2. So the volume function now becomes 1/3 pi H over 2 squared all times H. In other words, 1/3 pi times H cubed over 4. So 1 over 12 pi H cubed. Alright, so let's work with that down here then. If we just ddt that whole thing, then we're going to be ddting this thing. So that would bring a 3 down. 1 over 4 pi times h squared times dh dt. Okay, we got all the things that we need here, and we know all of these things. So let's just go ahead and divide things out. dh dt equals dv dt all divided by 1/4 pi h squared. So dv dt is 2. 1/4 is just there, times pi, and then h. What is h? It's 3. So 3 squared. So we get 2 over pi over 4 times 9. So if we just do that out to kind of make it look a bit nicer, then we get, alright, 2 times 4 is 8. We get 8 over 9 pi. And what are the units? dh dt. H is in centimeters, t is in minutes. So centimeters per minute. Alright, so this is just a bit of how to work with related rates and just some examples. So hopefully this helps. This is the end of the video, and I will see you in the next video.